Hi, tonight we're going to be talking about solving a system of inequalities. With solving a system of equalities, your answer tended to be just a single ordered pair or an infinite if they were dependent lines. When we talk about solving a system of inequalities, it's yeah, I've never seen it written algebraically. The way that you have to show your solutions to a system of inequality is a visual representation. It's generally like a region of your graph that's shaded, and what you're doing is showing that it's these set of ordered pairs are solutions to all three inequalities. So when you're solving a system, what you want to do is graph each inequality, and then the solution is where all of the overlapping is. Or all of the shading is overlapping. So let's do the first one, x greater than or equal to 2. That's a vertical line that passes through an x value of 2, and because it's equal to, it's going to be a solid line. Whenever you're graphing more than one line, it's important that you label your graphs. So that means next to this graph, you can either write x greater than or equal to 2, or I label them with letters. So I say that this is my inequality A, matches up with the inequality A. Okay, from shading, x is greater than or equal to 2. So on which side are there x values bigger than 2? It would be on the right-hand side. One way is to actually shade, and because we're doing a system, you could do that very lightly. Or what I do as my shortcut is I kind of draw an arrow to remind myself that it's this side of my boundary line that would be shaded. All right, y is less than or equal, or 3 is less than or equal to y is less than or equal to 3. That's a compound inequality. That means y is both greater than or equal to 3 and y is less than or equal to 6. So we'll have a horizontal line at 3 and a solid line. And then 4, 5. Another horizontal line at 6. And those are coming from the inequality B, that our y value has to stay in between those spaces. So with just the first two inequalities, our region, that would be our solution, is just kind of this open-ended rectangle over here, because we're shading to the right of the vertical line and we're shading in between these two horizontal lines. Okay, our last inequality would be x plus y is less than or equal to 10. So graphing the intercepts, solid line again. That would be inequality C. And to identify what direction we're shading here, if we plug in the ordered pair 0, 0, 0 plus 0 is in fact less than 10, so we would be shading towards the origin on that. So we're shading in on here. All right, so we have a solution set. Our solution set would be the region bounded by all three of those inequalities. Okay, so this is a visual representation of our solutions. Okay, any ordered pair that's on or in this region would be a solution to this system of inequalities. And you could do that by testing an ordered pair. We won't do that now. This region is called the feasible region. Region, if I can spell region. And it's called the feasible region because these represent the ordered pairs that are feasible or possible with this system of inequalities. So when we talk about solving a system of inequalities, we say identify the feasible region. It's the feasible or possible ordered pairs to satisfy all the inequalities. Another point of solving a system of inequalities is to find the vertices. So think back to geometry. A vertex is where two lines will intersect. So the vertices are the corners of your feasible region. In this case, we have 4 vertices. The bottom left-hand corner is the vertex 2, 3. And then we have the top left is the ordered pair 2, 6. And now these that are along the line x plus y equals 10, we can kind of verify, but it looks like this one is 1, 2, 3, 4, 5, 6, 7. So it's 7 and then up 3. And once again, you kind of want to double check that solution with your inequalities. 7 plus 3 does equal 10, so that is on that boundary line. And it's where y equals 3. And then this ordered pair is when y equals 6. So that must mean the x must be 4. Let's double check. 1, 2, 4. Yep, that's it. So we have identified or represented the feasible region graphically, and then we've also identified the vertices of our system. All right, thanks.